Section 6.1, example 5, writing an exponential model when the initial value is not known. Find an exponential function that passes through the points -2, 6 and 2, 1. So let's start with our equation. So we'll have f of x, since this represents a exponential function, we'll have a times b raised to the power x. And we have these 2 points. So let's find an equivalence for right now and see what we could do. So for the point -2, 6, when we input -2, we output 6. So input -2 is equal to ab raised to the power x, and that's equal to 6. So far we have an equivalence of a times b to the power -2. There should be a -2 here. B to the -2 is equal to 6. And let's see if we could compare that to anything in the second equation. The next one is using this point 2, 1. So f of 2, everywhere we see an x, we're going to plug in 2. And that's equal to +1. So here we have the equivalence a times b squared is equal to +1. So here I have an a to the power 1, also an a to the power 1. Let's set our equation equal to a to see how we could compare those two. If we get them equal to each other, we could just set those two equations equal to each other, possibly solving for b. So let's get that over here. On this side to move this over. So whenever we're multiplying with the same base, we could just add the exponents together. So dividing by b to the -2 is also the exact same as just multiplying by the reciprocal. So multiplying by b to the +2. So here, these two bases being exactly the same, we could add the exponents together. So 2 minus 2 gives us 0. So here we end up with b to the power 0, which is exactly what we need. So a is equal to 6b squared. And over here, let's see what we could do. So exact same thing. So one thing we could do is just divide both sides by b squared. Over here on this side, you could see that we end up with b to the -2. Or we could just multiply by that reciprocal. B to the -2, b to the -2. Over here, we have these two with the exact same base. B to the -2 plus 2 gives us b to the power 0, which is just 1. So a times 1 is a. Over here, we have b to the -2. And now that we have these two equal to a, we have a equals some sort of equivalence, a equals some sort of equivalence. We could just set those two equal to each other. Again, since they're both equal to a, we could just set them equal to each other. And now we could solve. So here, let's get all the variables next to each other. We are able to multiply and divide by them because b cannot be 0. B has to be a number greater than 1. So we could, let's see. Let's multiply both sides by b squared, so that way we get rid of this one. So multiply both sides by b squared. On the left side, b squared times b squared is going to give us b to the power 4. 2 plus 2 gives us 4. Or 6b to the power 4 is equal to 1. Over here, these two just simplify to 1. To get b by itself, we could divide both sides by 6. Now we have b to the power 4 is equal to 1 over 6. And we could just plug it into the calculator. So just like we did earlier, we could take the 4th root, giving us b is equal to 1 divided by 6 raised to the power of 1/4, the 4th root. And that gives us about 0.6389. And that's b. So we could quickly find a by just either plugging it in here or plugging it in over here. It looks like it'll be a little bit easier if we just plug it in over here. So let's come right back up this way and say that this is a is equal to b to the negative 2. B is our 0.6389 raised to the negative 2. We could get that, raise that to negative 2. And that gives us about 2.44948. So 4495. And now we have pretty much everything that we need. So let's see. Our equation originally was f of x is equal to a times b raised to the power x. A we just found out was this. So 2.4494 or 95 times b. Earlier we found this 0.6389, and we're raising that to the power x. And there you go. That's our function. If you have any questions whatsoever, please feel free to ask. Otherwise,